I've been working at our laboratory here for almost 10 years, 10 years in January. Was hired as a mechanical lab technician. I advanced to a leadership role. Um, Now in my current role of value stream manager, I took over leadership of our machine shop, which is specimen preparation, as well as all of our destructive test labs here. So here in Charlotte, we primarily test what are considered flight critical safety components. So this testing is required by the FAA. We want to provide safety first above everything. Want to make tomorrow safer than today here at Element. We have several very large forging operations we work with our end users being just about every major player in the engine business. We also do non-aerospace work, nuclear qualifications, just standard structural steels. You name it, we've probably done it. Bunch of other bespoke defense work as well as failure analysis. Offer a full suite of test specifications and accreditations that we can do here. We primarily developed this capability to test the CFM 56 high pressure turbine blade stage 1. We had a request from a customer to do some qualification work for their blades they were forging. These are extremely small geometries. I have kind of a example on my desk here. So we are able to extract a standard cylindrical round specimen from the root section of this turbine blade. These are very extremely complex geometries. There's holes for cooling that are EDM cut into them. There's flow of cooling gas that flow through these so they can operate at critical temperatures and pressures and not melt. These are extremely small areas of material to work with. So we invested in a wire EDM to do blank extraction, primarily extracting 1/8 inch cylinders, for which we can create a test specimen and actually thread and low stress grind this specimen. I'm not aware of any other laboratories being able to low stress grind specimens this small. So you have to have the right equipment. Purchase 2 wire EDMs for precision blank extraction. We also bought a small size tensile frame. It's electric. It has a max load of 10 kilonewtons, which is about 2,200 pounds. So this is the right size for miniature size specimens. We have this outfitted with a electric resistance furnace capable of exceeding 2000 degrees Fahrenheit. The machining of it also a challenge. So we have the right size wheel for this. We also bought tooling, invested in tooling and grinding capabilities to turn and grind these specimens. So pretty much every single one of our aerospace customers requires low stress grinding preparation. That's very important for our approvals in our end use customer market. The smaller you go, the more precise you have to be. So, a difference of 0.5 thousandths of an inch in diameter or concentricity on like a full size specimen is leagues and bounds different than what, a specimen with a 0.07 inch diameter. You just have to be more precise. There's less margin for errors. A lot of the ASTM standards actually reference this. Sub-size specimen machining and testing is more difficult. It actually says that in the standard. The smaller you go, the more precise you need to be. So we take defense work very seriously. We're ITAR restricted, EAR. We have a great deputy in charge of that here in Charlotte locally. There's these special rooms that get set up that actually bypass our internal server so that no sensitive data is stored in a non-restricted area. We have done some, previous work on some like missile projects. We have all kind of end use markets that we would like to support. We really just want to be available for what our customers need. And we take that very seriously here. We actually, in this year alone, we've increased our square footage floor space by 150%. So where I'm sitting now in my new office is a brand new lease that we took on in January. We are outfitting this space with creep and stress rupture machines, tensile frames, machining equipment. There's actually 2 5-axis grinders that we've installed this year in the shop. It's a new capability for us. We are onboarding CBN grinding, which makes a big difference in cycle times. Our capacity is primarily in creep and stress rupture testing. So we're actually completely doubling our capacity with the current investment. So we had a network of about 170 machines. We're going to be over 400 by the end of this year.
Wow.
We're also investing in capacity with tensile testing, with our creep and stress rupture testing coming online. We can certainly fill up our entire laboratory with work. We also added additional plunging EDMs, which some of our prime customers use. It's one of the best practices for blank extraction from nickel-based superalloys, which is primarily what we're testing here. These are very sophisticated materials. Not the easiest thing in the world to machine and test, but we are absolute experts in it at this point, and certainly always looking to do it better and faster and deliver more good, valid tests for our customers. You know, a customer asks for something that we've never done. You know, some people balk at that and say we can't do it. Our question to the customer or to ourselves is, you know, how can we make that happen for you? So there's specific requests we get for strain to failure on tensile work that we developed methods for. There's these bespoke specimen geometries that we've never, you know, manufactured or tested before. Done a lot of those. We also run statistical process controls on our routine work. You know, if the customer does have a question, we're happy to investigate it, throw an engineer at it, make sure that the customer is satisfied, and we can reserve capacity for you. You know, if we are able to anticipate the work coming to us, have faster turnaround time, have less questions at inception. We have a great commercial team here at Element. We do a lot of R&D testing, doing some very long-running projects. Did recently win some work for a extremely low stress creep, which is another potential application for my test frames that are direct load for these miniature specimens.